2.1. Describe the behavior of electrostatic charges and the properties of fields associated with them. So there are common examples of the effects of electrostatic charge which we've done in year 9 and 10. Most of them you would know as rubbing the Perspex rod with a cloth and bending water. Some of you have experienced electric shock while getting out of a car or even going down a slippery slide. So what that means is there's two types of charge. There's a positive and a negative charge, as Benjamin Franklin suggested, where like charges repel and unlike charges attract. So when an object is said to be neutral, there are no unbalanced charges. It contains equal amounts of positive and negative charge atoms or particles, as known in your junior years. So what electrostatics means is when there is an imbalance of these charges in the charged particles. So if there is a deficiency of electrons, that means there is a net positive charge, as shown in the diagram on the bottom right. If there is an excess of electrons, there is a net negative charge. Okay, so there is an excess of a negative charge. So we know that electrostatic charges are due to small charges in atoms. When we've learnt it in our atomic structure in our junior years, we've learnt about electrons and protons. So when we're discussing charged particles, you need to refer to them as electrons and protons, and we know that electrons have a negatively charged function, while protons have a positive charged function. So if an object has a negative charge when it gains an excess of electrons, and a positive charge when it loses electrons, it is only the electrons that move in this process of charging a material